Okay, today we're going to talk about how to make a fancy bar graph in R. And here I have RStudio open, which certainly helps develop some nice things in R fairly easily. And the data set I'm using here is called GISS-Temp. So what this is, it's a collection of temperature anomalies collected at various meteorological stations around the world, okay, since 1880. So it's located, the locations are either by specific geographic region or by northern or southern hemisphere, and there's also a global temperature anomaly reading, which is simply the average of the northern and southern hemisphere. This data comes from NASA, the Goddard Institute of Space Studies, and you can download it yourself as a CSV file. Just Google GISS-Temp here, and you'll find it. And you'll also find a lot more information about how the data is collected and really what it means or implies. Essentially, it's supposed to show the an estimate of the global surface temperature change over time. And if you import it, you can use the import feature here in RStudio. So to do our bar graph, we're going to use ggplot. And if you don't have it, you can go to Tools and Install Packages and simply type ggplot and go ahead and install that way. So I've already installed ggplot on my system. I'm just going to load the library like that, and then we can go ahead and get started. So first we're going to type in ggplot. We're going to add in our data set, which is GISS-Temp. And there's a autofill feature there you can use. And then we're going to add our aesthetics. So we're going to add an X variable, which will be year, and Y equals this global average temperature. You don't need to specify X equals and Y equals. You can just add in the variables in the correct positions there for X and Y. We hit enter here, and basically we've initialized the graphics environment. So we get kind of a clean slate here to work with. So we're going to make a bar graph. We're going to use the up arrow key to get back the last syntax. And we're going to pull a geom. And you can see that when you type the first few letters there, it actually pulls up all the different ones you can select along with a description on the right. So I'm going to pull the bar one up, hit enter, and it blows up on us. So what's happening here is the bar option defaults to counts, so it's thinking the height of the bar is proportional to some count, but really we've kind of specified that there's a variable that's here that's continuous, and we need to override that. So we'll pull that back up, and we'll use a simple command, identity, stat equals identity, and now it works. So you can see this first bar right here is actually this minus 19. This minus 10 will be the next bar over, and so forth. So now we have a nice bar graph. Okay, so you can see that prior to a certain year, things were pretty much in the negative area for anomalies, and then kind of a period of flatness in a way, and then suddenly this kind of big change to the more positive temperature ranges. So I don't like these colors too much, I mean, they are descriptive, but we can even get better than that. So what I'm going to do here is add another aesthetic where I make my fill equal to the variable glob. So what this does, it'll make the color proportional to the magnitude of the temperature. Okay, and it also gives that kind of a gradient key here as well. So again, this helps a little bit more to differentiate the data, so it's a little bit more clear to the observer or to the user what's going on. We also need to add some titles and so forth. So again, we'll just add a title. We'll call this global temperature anomaly. And we can also add our X and Y labels. And we'll make our X label, call it measurement year. Got to make sure the spelling is correct here because this doesn't do automatic spell check. And we'll just call this degrees F. Okay, now we have an even better graph here. So we have a little bit of, descriptors of what the axis means, different axes mean, and we have a title and so forth. Now I'm not too excited about this scaling here for the measurement year. It's too broad. The breaks are too large. So it's kind of hard to figure out exactly, what's going on here. You have to do a little, addition and subtraction and so forth. So let's go ahead and make that finer. And we'll add scale X continuous. And we'll say breaks equal. So this data goes from 1880 to 2014. We'll make it in 10-year increments. And again, this helps a lot. Okay, so when somebody's looking at this, they can just go right to the point where they're looking for. It's a lot easier to figure out, what the different years are doing here. So that's a lot of information we've already covered in a fairly small amount of syntax. And then we can even change up the color scheme itself. So let's go ahead and do that. And we're going to scale fill gradient. The nice thing here, you can specify low color. Let's make it dark cyan. And a high color, dark orange. And you'll have to look up these, spellings and what colors are available to ggplot. And we can even name our legend as, let's say, average degree F. So now what do we get? And we even get a better graph yet. Okay, so this is even more, really brings the user into the graph a little bit more here. And then when we're done, we can export it, and we can save it as an image or a PDF. We can copy it to the clipboard, and make some more modifications, maybe change the width, and we can certainly copy this into a presentation or something like that. So really what the whole point here is that we generate a fairly sophisticated graph based on very simple structures. So we built a structure, tested it, then added a little bit more to it, tested it a little bit more, and so on. So you can generate this complexity or this type of graphic just by continuing to add more and more features onto it. And there are more features here than I've shown. I mean, you can change this axis over here, you can change the background palette here, and there's actually quite a multitude of things you can do with this. And some people I know may say, well, why not just go to a CAN package, and just generate it. You can do that, but sometimes you'll need to customize it. And what I found is CAN packages, they have graphics that seem to do most everything, but there are times when it's like, I wish they just would have had this one more feature. So ggplot, gives you the option of adding just that one more feature, okay, or something unique. And also, I know, people say, well, R takes time, you got to write out the syntax and all that, but what you're doing is you're actually thinking about your graph and how to develop it. I know a lot of times in the business world, it's about not generating a key graph, but how many graphs can you generate? And a lot of times that's meaningless, and the user becomes actually numbed to so many graphs. So this actually helps you develop a key graph of your information that people can really gravitate to, and you can get the most information out to it. The other thing too is, if you're an R user, the learning curve is kind of steep here, but In the beginning, I remember it was very difficult to write the syntax, but the more and more I use it, over time, the faster and faster you become. And you can also save the syntax as a script file and then reuse it, and pass different variables to it and so forth. I hope that helps. There's a lot more to ggplot and of course R out there. Plenty of stuff online, and you can Google things like if you want to change the y-axis here, you say how to change the y-axis in R or ggplot, and you'll get a list of things that you can look at. If you get in a jam, you can always Google your way out of a jam just by typing in the error message, or just researching it that way. So the nice thing about R, it's got a lot of information out there, a lot of user groups that can really help you along. Anyway, hope that helps. Kind of a general introduction into ggplot and how to make an interesting graph.